A displacement reaction, also known as a replacement reaction or single replacement reaction, is a type of chemical reaction where an element or ion moves out of one compound and into another. This occurs when a more reactive element displaces a less reactive element from its compound. In simpler terms, it's like a game of musical chairs, where one element replaces another in a compound. To understand displacement reactions better, let's delve into the principles behind them. Explore the factors that influence their occurrence, and examine examples to illustrate their significance in chemistry. Principles of displacement reactions. 1. Reactivity series. The reactivity series, also known as the activity series, is a list of metals arranged in order of their reactivity. In a displacement reaction, a more reactive metal will displace a less reactive metal from its compound. For example, if metal A is more reactive than metal B, metal A will replace metal B in a compound, forming a new compound with metal B. 2. Bionic compounds. Displacement reactions commonly occur between ionic compounds, where positive and negative ions are attracted to each other due to electrostatic forces. When a more reactive element displaces a less reactive element from an ionic compound, a new compound is formed. 3. Redox reactions. Displacement reactions are a type of redox oxidation-reduction reaction, where there is a transfer of electrons between reactants. The more reactive element undergoes oxidation loses electrons, while the less reactive element undergoes reduction gains electrons. Factors influencing displacement reactions. 1. Reactivity of metals. The reactivity of metals plays a crucial role in displacement reactions. Metals higher in the reactivity series can displace metals lower in the series from their compounds. For example, zinc can displace copper from copper sulfate solution because zinc is higher in the reactivity series than copper. 2. Concentration and reactivity. The concentration of reactants can affect the rate and extent of displacement reactions. Higher concentrations of reactive metals or ions increase the likelihood of displacement reactions occurring. 3. Temperature. Temperature can influence the rate of displacement reactions by affecting the kinetic energy of particles. Higher temperatures generally increase the rate of reactions by providing more energy for collisions between particles. Examples of displacement reactions. 1. Zinc displacing copper from copper to sulfate. ZnS++ QSO underscore for AQ. Right arrow ZnSO underscore for AC++ QS. In this reaction, solids ing Zn is added to a solution of copper to sulfate QSO. Zinc, being more reactive than copper, displaces copper from the compound, forming zinc sulfate ZnSO and solid copper. 2. Iron displacing copper from copper to chloride. Fe++ to Qcal underscore 2AQ. Right arrow Fecal underscore 2 AC2Q. S. Here, solid iron Fe is add.